On March 14th, 2024, a tornado outbreak occurred across portions of the plains and Midwest, resulting in several damaging tornadoes. Let's take a look at how the Storm Prediction Center's forecast performed for this event. On the day before the severe weather outbreak, the Storm Prediction Center issued the severe weather outlook for March 14th with a slight risk extending from portions of the plains through the Midwest. There was also an area of enhanced risk stretching across portions of Texas, Oklahoma, Arkansas, and Missouri. The corresponding tornado outlook had a large area of 2% probability stretching from portions of the plains through the Midwest and much of Ohio. A smaller area of 5% probability was embedded within this area. In the early morning update of the severe weather outlook on the 14th, the area of slight risk was expanded through portions of Indiana and Ohio. Likewise, in the early morning update of the tornado outlook, the 5% tornado probability area was expanded to portions of Indiana and Ohio. In addition, a 10% tornado probability was added to portions of Oklahoma, Arkansas, and Missouri, indicating an enhanced risk for tornadoes in this area. Now, let's see how this outlook performed compared to how the event actually unfolded. Overlaid on this severe weather outlook issued at 2 a.m. on March 14th are the actual tornado reports from that day, denoted by red dots. As you can see, the tornado reports were pretty much contained within the risk areas. However, it is interesting to note that larger clusters of tornado reports occurred in the area of slight risk across portions of Indiana, Ohio, and Illinois, rather than in the area of enhanced risk where only a few tornado reports occurred. Likewise, here tornado reports are overlaid on the corresponding tornado outlook graphic. Many of the larger clusters of tornado reports occurred within the 5% risk area, except for a cluster in northern Ohio. It is interesting to note that there were no large clusters in the 10% area where one might expect them to be. But this is not surprising because the computer models currently used by forecasters cannot predict exactly when and where tornadoes will occur. At best, forecasters can use model predictions to identify areas where the formation of supercells and tornadoes are more likely, which is why probabilistic forecasts such as this one are issued by the Storm Prediction Center. This forecast, in my opinion, verified well because nearly all the tornadoes that occurred happened in areas that the Storm Prediction Center outlined as having a non-zero probability of a tornado occurring. Let's examine how one of the models, the NAM, fared around the time when a tornado actually occurred. Let's now look at what the forecasted severe weather parameters look like. This forecast sounding valid at 8 p.m. Eastern Time is from the 12Z run of the NAM. It predicted 59 knots of deep layer shear, 294 meters squared per second squared of 0 to 1 kilometer storm relative velocity, 384 meters per second squared of 0 to 3 kilometer storm relative velocity, and 2,208 joules per kilogram of CAPE. This depicts an environment conducive for the formation of tornadoes. But what was the storm environment like around the time that the tornadoes actually struck? Now, let's take a look at the actual observed data around that time. This data collected for this sounding was taken by a weather balloon at 8 p.m. on the 14th. The actual observed values were 66 knots of deep layer shear, 347 meters squared per second squared of 0 to 1 kilometer storm relative velocity, 460 meters squared per second squared of 0 to 3 kilometer storm relative velocity, and 1,249 joules per kilogram of CAPE. Except for mixed layer CAPE, the deep layer shear and storm relative velocity were greater than predicted. This meant that there was more spin available in the inflow for storms to ingest, making the formation of tornadoes more likely than originally predicted. This difference illustrates an important concept. Computer models are not perfect, nor is the data fed to them. The atmosphere is very complex, and computer models perform imperfect simulations of atmospheric dynamics. In addition, observation data that's ingested by the models are relatively sparse, and measurements can contain errors. In other words, what models predict may not actually occur as forecasted. A couple of lessons can be learned from this tornado outbreak. In areas outlined as having a risk of tornadoes by the Storm Prediction Center, the greatest number of tornadoes may not necessarily occur in the highest risk area, and even in lower risk areas, tornadoes are still a possibility.